Okay, so let's go do the last part, which is part number 2, and that is we'll start simply with current dividers. Current dividers, like voltage dividers, it's another formula that we used here. No, wait, we don't have a formula for the current divider actually, but it's like exactly the same as the ones that we use in circuits with resistors. And we want to like find the current through one resistor and the other when this splits in two. Alright, so let's get started with this one, which is a pretty simple one. We only know the current at an angle of 0 degrees. We know R is got a resistance of 6 ohms and this XL is got a resistance of 8 ohms. Of course, we can do it the long way, calculate the total resistance, then divide it, find the total current, and then from there we just split it in two. Or we can just apply the current divider rule, which basically it's IR equal with ZLIT divided by ZR plus ZL. Alright, now IT, this one is the total current, which we know is 30 amps, and this ZL value is the XL value with that angle, which is basically 8 angle of 90 degrees. And the only difference is it's when we calculate this one, you want to find out the value for this ZL. Well, you just put CL in here and you'll find the value for the current through R. If you want to find the current through IL, then you replace this one with ZR, and then you'll find the current through IL. Again, it's exactly the same one as in the normal circuit. So when we calculate, we can do it like this. So it will be 8 angle of 90 degrees multiplied by 30 times the angle of 0 degrees. No, 30 angle of 0 degrees, all divided over 60 degrees plus 8 angle 90 degrees. So this will be equal to 240 amps angle of 90 degrees over 6 plus J8. Again, the problem is this is rectangular form, so we need to make it into a polar form. So Z is equal with square root 6 squared plus 8 squared, which is equal to 10. And then the angle is equal to 10 minus 1, 8 over 6, that's equal to 53.13 degrees. Therefore, 240, you can still say it, yeah, 240 amps at an angle of 90 degrees divided by 10 at an angle of 53.13 degrees. And that would be equal to 24 at an angle of 36.87 degrees. Now this one will be the value for IR. So IR is equal to 24 amps at an angle of 36.87 degrees. Now we just need to calculate for IL. So IL will be equal to ZR this time times IT over ZR plus ZL. This will be equal to 6 angle 0 degrees multiplied by 30 at an angle of 0 degrees over 10 at an angle of 53.13 degrees. And that will be equal with 80 at an angle of 0 degrees over 10 at an angle of 53.13. We just take the previous number from the previous exercise. And so we can easily determine it to be 18 at an angle of minus 53.13 degrees. And this will be IL. Alright, now we can like check the answer, see if it's correct. So we can do IR 2 dots X is equal to 24 cos 36.87, that will be equal with 19.2. Y will be equal with 24 sine 36.87, that will be equal with 14.4. Together there will be 19.2 plus 14.4. Alright, and then IL will be equal of the X value of 18 cosine minus 53.13, which is equal to 10.8, and Y will be equal with 18 sine minus 53.13, that will be equal to minus 14.4, which will give us 10.8 minus J 14.4. So when we add them together, we get IT, which will simply be 30 plus J0. So therefore IT is equal with 30 at an angle of 0 degrees. The exact answer, because you do 19.2 plus 10.8, that will simply give you 30. Alright, so this kind of proves that the divider rule works. That's how you check if you've done it properly or if you've done it correctly. So now this one is kind of a simple example where to use this rule. Another one that you can use it on, it's in this one here where you have multiple components. For example, you have a resistor and inductor in series, and both of them are in parallel with a capacitor, and a current of 10 amps, and this time with an angle of 30 degrees is coming through, which makes the problem a little bit more complicated, because first you need to calculate both of them at the same time, like the current through both of them. So the way we can write it as IR and L, because resistor and inductor are in series, so I'll just put a line between them. It's equal with ZC, the capacitor, multiplied by IT over ZC plus, and then we do a bracket, ZR plus ZL, because you add both of them, because they are connected in series. So that would be equal with, let's see here, 4 ohms at an angle of minus 90 degrees multiplied by 10 at an angle of 30 degrees divided by minus J4, because the capacitor has got negative value, plus 2, the resistor just says as a real number, plus J16, because the inductor it's a positive value of 90 degrees. So then that would be equal to 40 at an angle of minus 60 degrees, 2 plus J12. And there we have it. This is the first step. The second step will be to convert the rectangular form into a polar form. So then Z will be equal with square root 2 squared plus 12 squared. That will be equal to 12.17. And then the angle will be 10 to the minus 1. 12 over 2, that will be equal with 80.54 degrees. Alright, so we got these values. Now let's go to the next one, which, no, actually let's write it. So then IR L will be equal, basically the current through this will be equal with 12.17 at an angle of 80.54 degrees. Alright, now let's go to the next one, which will be IC, which is equal with ZR and ZRL, basically the ZR and ZL values added together times the current IT, the total current, over ZRL plus ZC. Basically this one staying the same. That will be equal with 2 plus 16J times 10 to the angle of 30 degrees. And all of it will be divided by 12.17 at an angle of 80.54 degrees. Alright, so then Z will be equal with square root 2 squared plus 16 squared. That will be equal to 16.12. Okay, then we need to calculate the angle, which will be equal with 10 to minus 1, and that will be 16 over 2, and that will be equal with 82.87 degrees. We are basically calculating for this one here, if you didn't realize, for ZRL, because we don't have the polar form of this form. We only have the polar form for this one here. Okay, so then we can replace this value here. So that would be IC equal with 16.12 at an angle of 82.87 degrees multiplied by 10 at an angle of 30 degrees, all divided by 12.17 at an angle of 80.54, and that will be equal to 161.2 at an angle of 112.87, all divided by 12.17 at an angle of 80.54, and then these ones will be equal with 13.25 at an angle of 32.33. Alright, and there we have it. This one will be the current in IC. This will be 13.25 at an angle of 32.33. And we can actually check our answers again by simply doing IT equal with IRL plus IC. So then IRL will be X, which is 3.29, cosine of minus 140.54 is equal to 1 minus 2.54, and then Y is equal with 3.29 sine minus, okay, sorry about that, my sister put the dog in here, and so you might hear her in the background. So sine minus 140.54, that will be equal with minus 2.09. Together that will give us minus 2.54 minus j.209. Now we calculate for IC, we convert it to a rectangular form, which will be X is equal with 13.25 cos 32.33, that will be equal with 11.2, Y is equal with 13.25, and now my dog wants to get out. Just a second. Alright, let's get back where we are. So 13.25 sine of 32.33, that will be equal with 7.1, that will be 11.2 plus j 7.1. Alright, so now IT will be equal with minus 2.54 minus j 2.09 plus 11.2 plus j 7.1. Then that will be equal with 8.66 plus j5. Now we convert this value back into its polar form, so z is equal with 8.66 squared plus 5 squared. That will be equal with 10. And the angle is equal with tan minus 1, 5 over 8.66, that will be equal with 30 degrees. Therefore, IT is equal with 10 at an angle of 30 degrees. And that's our answer, which matches our input current, our I total. So again, this one, it can be short if you don't want to prove it that it's actually the correct answer, but you want to check to see if it's the correct answer, then it will be a bit longer. Anyway, now this was the current divider rule, and now luckily for you, and I say luckily for you, I don't know, maybe you want to like hear more and want to see me do more problems, we are coming to the last one, which is a parallel AC circuit with multiple components. And not only is it a parallel AC circuit with multiple components, but I'll also show you how to do this to transformation from a series circuit to a parallel circuit, and from a parallel circuit to a series circuit, which will be, in my opinion, kind of interesting. Anyway, so let's get started. Just let me get ready here. There you go. Alright, first of all, what do we notice? Well, none of these ones are XL values or XC values. None of these ones are in ohms. Only the resistance is ohms, 20 ohms and 80 ohms, 12 millihertz and 24 millihertz, and 160 microhertz, no, microfarads, that's henries, that's farads, and 40 microfarads. And it's got a current, a peak current of 15 amps. It's got a frequency of 159.15. Alright, so what do we do first? Well, first we calculate these values that are in parallel and make them in an only one parallel system. So then RT will be equal with R1 parallel with R2, and that will be equal with 20 in parallel with 80, and that will be equal to 16 ohms. LT will be equal with L1 parallel with L2, because inductors work as resistors when it comes to this. That'll be 12 milli parallel with 24 milli, that's equal with 8 millihertz. And then the last one, which is CT, C total, it's equal with C1 plus C2, that one is equal to 160 micro plus 40 micro, and that will be equal to 200 microfarads. Alright, good and nice. So now we know the values in farads, but we don't know how. We need to make them in ohms. It's not enough to just make them in farads. So we do I, it's equal with, and then we do 15 sine 2 pi multiplied by 159.15 times t. That will be equal with 15 sine 1000 t. Therefore, now because we know the angular velocity, now we can calculate the XL and the XC. So XL will be equal with 8 milli multiplied by 1000. That will be simply equal with 8 ohms. And then XC will be equal with 1 over 200 micro multiplied by 1000. That will be equal with 5 ohms. Okay, and we can also just calculate the RMS value of the current as well. So I is equal with 15 times 0.707, and that will be equal with 10.6. And this is the RMS value, the value that we use to calculate an AC circuit. Okay, so from all of this, we can redraw the circuit like this. We can draw it like a current source. We can put one resistor, one inductor, and one capacitor. There you have it. And this one will be RT, our total, which will be 16 ohms, XL, which will be 8 ohms, and then XC, which this one will be 5 ohms. And here that will be I, which will be 10.6, and an angle of 0 degrees. There you go. So now what we do? Well, we will have to calculate the total resistance. So then ZT will be equal with 1 over 16 angle of 0 degrees plus 1 over 8 angle of 90 degrees plus 1 over 5 angle of minus 90 degrees. That one will be equal with 1 over 0.0625 angle of 0 degrees plus 0.125 angle of 90 degrees plus 0.2 angle of minus 90 degrees. Alright, so these are the three numbers that we have. We can convert them in rectangular values, so that will be equal with 1 over 0.0625 plus j 0.125 minus j 0.2. So then the answer that we'll get will be 1 over 0.0625 minus j 0.075. Alright, so that's are the values. And now before we change it, we make it fully into the total resistance with an angle, we need to calculate the polar form of it. So then Z will be equal with polar form 0.0625 squared plus 0.075 squared. That will be equal with 0.098. Then the angle will be equal with 10 the minus 1 minus 0.075 over 0.0625. That will be equal with minus 50.2 degrees. Alright, so now we have this polar form. So then ZT will be equal with 1 over 0.098, an angle of minus 50.2. That will be equal with 10.2 at an angle of 50.2 degrees. Okay, now the next step will be to convert ZT back to a rectangular form. So no, actually we don't need to do that. Let's say our next step is to actually calculate the total voltage, because you know the current and you know the ZT. Then E will be equal with I times ZT, that's equal with 10.2 at an angle of 50.2 degrees multiplied by 10.6 at an angle of 0 degrees, and that one will be equal to 108.12 an angle of 50.2 degrees. All right, so now that we know the voltage, we know that in this case here, the voltage will just simply spread across all three of them. So because it does spread across all three of them, then we can simply calculate the current through each one of them. So let's go to the next page. So then IR be simply be equal with 108.12 at an angle of 50.2 divided by 60 at an angle of 0 degrees, and that one will be equal with, let me do this one quickly, 108.12 divided by 16. Okay, I'll put 100 by 16. That'll be 676, maybe 6.76. And let's go to the next one, which this one divided by this one, oh, it's just the same angle, keep maintaining the angle of 50.2 degrees. All right, now let's go to the next one, which will be IL, which will be equal again with 108.12, an angle of 50.2, which is the voltage, divided by the resistance, which is 8 at an angle of 90 degrees, and that one will be equal with 108.12 divided by 8, that's 13.52, and then the angle will be, let's see, 90 minus 50.2, yeah, let's do it like that. That would be minus 39.8. I wrote it the other way around. I wrote it the opposite way. That's why it's a positive and it's not negative on the calculator. Okay, so now I have IL. Now I need to just find out IC, just equal with 108.12, an angle of 50.2. Again, the voltage divided by 5 at an angle of minus 90 this time degrees, and that one will simply be equal to, let's see here, so 108.12 divided by 5, that will be 21.62, let's say, so 21.62 at an angle of, let's see here, you add them together, so plus 90, so that will be 140.2 degrees. All right, so we found out all three total currents. All right, what we can do now, well, now we can okay, so let me think for a second. So the way that it might sound strange and complicated, but ZT, the total resistance with the angle, it's actually a representation on how to transform a, how is it called, a parallel circuit into a series circuit. So if I have my notes here, yeah, they are. Okay, just to make sure. So then ZT, we know, it's got a value of, let's see here, value of ZT, there you go, 10.2 at an angle of 52. 10.2 at an angle of 50.2 degrees. Now, to transform the parallel circuit, this parallel circuit into a series circuit, this parallel circuit into a series circuit with only two components, then we will need to transform this ZT into a rectangular form. And that rectangular form is got two components, which is the real number, and that is the resistor, and the second component is the imaginary number, which in our case it's either an inductor or a capacitor, depending if the number is positive or negative. If J is negative, then it will be a capacitor. If J is positive, then it will be an inductor. So ZT, two dots, X will be equal with 12.2 cosine 50.2. And that will be equal with, so it's 10 not 12. So 10.2 times cosine 50.2, that'll be 6.53. And for Y, it will be 10.2 sine 50.2. That will be equal with sine 50.2 that would be 7.84. So together it would be 6.53 plus J 7.84. And now we can redraw the circuit. Remember, it maintains the same source as this. The current source, one resistor, and one inductor in series, very importantly. So we can replace that entire circuit with this one now, 6.53 ohms, and this J value will be 7.84 milli. No, it won't be. No, it will be an XL value, wouldn't it? Yeah. It can either be millihertz or it can be XL. And that is because XL will be equal with 7.84, and then if therefore WL it's no, okay, and that one is equal with WL, therefore L is equal with XL divided by the angular velocity, therefore it's 7.84 divided by 1000, and that one is equal to 7.84 millihertz. So in case you want to like put it as a how is it called, in case you want to rebuild it and use it in your circuit instead of using this very long circuit, and you want to have a simple two-component series circuit, you can replace it with this, and you can put 7.84 millihertz here and the resistor 6.53 ohms here. But you're going to need to use the XL to like further our calculations, but to know that the idea is basically that, and that's the principle of it. All right, and remember the current is the same, it will still be 10.6 at an angle of 0 degrees. Now, this is, I know this seems complicated, it seems like very strange, but it does work like this, because the total resistance in this circuit will be the same total resistance as in this circuit. And the reason this is an inductor and not a capacitor is because this J, it's a positive plus 5.84. If this J was negative, was minus J 7.84, then this one won't be an inductor, this would be a capacitor. All right. So in case you want to transform this big circuit into a simple two-component series circuit like this one here, you just do that. And also it's the introduction to this formula here that can make series components into parallel components. I'll show it to you how you do that. And if you don't think that this is the same as this circuit here, then I can also prove it to you, because we calculated here the, as it called, the total current, the total voltage, yes, in this one here and this one here, this is the total voltage. So if this circuit is true, then it should have the same total voltage. So let's calculate the total voltage so I can prove it to you that it does work the same way. So E is equal with 6.53 plus, no, let's actually write like this. Let's equal ZT, which is this one here, multiplied by 10.6. So therefore 10.2 at an angle of 50.2, because it's the same one, it's the same angle, you multiply by the current 10.6 at an angle of 0 degrees, and that would be equal with 108.12 at an angle of 50.2 degrees. So there you have it, it's exactly the same. And why is that? Well, it's because these two will still make the total ZT. And how does that work? Well, again, the resistor, it's a pure number, so the resistor just is a 6.53, and the imaginary number, which will be the inductor in this case, will be a positive J of 7.84, and that's why ZT is the exact same number as this one, making it the exact same polarity as the ZT that we calculated previously. All right, so this way, so let's recap what we found out. So we found out the currents, the three currents going through it. Now we simplified the circuit, we found out the three currents going through there. So we know the current going through here, and through here. And if you want to be a bit more specific, like you want to find one of them specifically, well, actually let's do that, I don't mind. Actually, we'll do it after the next step. We can also apply current divider that we just learned previously in these cases to find out the component values. But first let's do this one here. Let's finish it off. So next thing that I want to show you is how to use this formula to make a series circuit into a parallel circuit. So basically we have this form here, and maybe you want it to be in parallel. Well, then you simply write the formula R in parallel is equal with R in series plus XS in series, they will be squared, both of them, divided by R in series. So that will be equal with 6.53 squared plus 7.84 squared divided by 6.53 squared. No, that's just 6.53, sorry about that. That will be equal with 15.94 ohms. And for the imaginary number xp, that will be equal with rs squared plus xs squared again, but instead it will be divided by xs. So that will be equal with 6.53 squared plus 7.84 squared divided by xs, that will be 7.84. So that will be equal with 13.28 ohms. So now we can like just simply write it like this one. We write here as the current, we put here one resistor, and we put here one inductor because it's a positive number. If it was negative, then it will be a capacitor again. So R will be 15.94 ohms, and then XL will be 13.28 ohms. And then the source I stays the same as 10.6 at an angle of 0 degrees, and the current also stays the same as 108.12 at an angle of 50.2 degrees. Alright, and let's see here. So we can actually calculate it if you want, like IXL. We can apply the voltage divider rule, or any rule you want really. We can do like IXL will be equal with 108.12 divided by 50.2 degrees, and that will be over 13.28, and that will be equal with 8.14 at an angle of minus 39.8 degrees. And you may say like, okay, so what is this 8.14 at an angle of minus 39.8 degrees mean? Well, what it means basically, it's what is left of the circuit. So this IXL is basically the current going through these two components, this section of the circuit. Oh, did you not see it? Sorry, there you go. There was like what I was calculating, in case you didn't see it. But anyway, it's through these two here. So how do we calculate this? How do we check this out? Well, it's kind of simple. So we know the current is here, which is 10.6, yeah, RMS. And we also know the current, the resistor current, which is, it should be somewhere around here. It's on this side. Yeah, it's on this side, which is 6.76 at an angle of 52 degrees. So then theoretically we can just calculate it by taking away the maximum current by IR, and then what's left will be this section here. So let's do that. So then we can do, let me see, can you see? Yes, you can. Okay, so then we can do I minus IR, so that will be equal with 6.76 at an angle of 50.2 minus I, which is 10.6 at an angle of 0 degrees. Okay, so let's see, do I have the R and I values in X form? And the answer is no, I do not have them in X form. Okay, I'll move this paper here. I'll get a new fresh one so we can keep going with the calculations. Alright, so now we need to convert the I into oh sorry, I put it the wrong way around actually. It's supposed to be 10.6 angle of 0 degrees minus 6.76 at an angle of 50.2 degrees. There you go, that's the right order. Alright, so x value will be equal with 10.6 cos 0 degrees, so that will be equal with 10.6, and then y will be equal with 10.6 sine 0 degrees, and that will be equal with 0. I think that's the right answer, isn't it? Let's see, 10.6 sine times sine of 0. Yeah, that's 0 basically. And if it's cosine, it should be the same number. Yeah, it is the same number. Okay. So that is, it's in ohm form, so 10.6 plus 0j. Now for IR, then that will be, x will be equal with 6.76 cosine 50.2. That will be equal with 6.76 times cosine 50.2. 4.33, let's say 4.33, and then y will be equal with 6.76 sine 50.2. that will be equal with, okay, times sine 50.2, that'll be 5.2, let's say, so 5.2 together there will be 4.33 plus j 5.2. all right, now you just need to take them away, so plus 0j minus 4.33 plus j 5.2. all right, so then that will be equal with, so 10.6 minus 4.33, 6.27, and then minus j 5.2. all right, so next step will be to sorry about that. all right, next step will be to convert this one into polar form. So then z will be equal with square root 6.27 squared plus 5.2 squared. That will be equal with, so 6.27 squared plus 5.2 squared. That will be equal with 8.15, let's say 8.15. But actually, what was the answer? Was it like 8.14, was it? Yeah, it was 8.14. Let's just leave it 8.14 then for the sake, because it was a small difference anyway. And then angle will be equal to 10 to the minus 1. That will be equal with, let's see here. So that will be 5.2. No, 10 multiplied by minus 5.2 over 6.27, and that will be equal with, so then 10 to the minus 1 minus bracket 5.2 over 6.27. that will be equal with minus 30, yeah, there you go. That will be equal with minus 39.8 degrees. And to get that to give us 1.14, then angle of minus 39.8 degrees. So as you saw, we just calculated, we just get rid of this section here, and the current that we got left coming to the inductors and circuits was 8.14 at an angle of minus 39.8 degrees. And that number, this number here, is exactly the same as this number that we calculated it here when we calculated in parallel. That is the exact same number, which means it's correct. That is the current going through them, meaning that this is the total current going through here, helping me prove you that the problem was correct and that this solution is viable. Well, of course, it doesn't always work like this. It works in this case because the components are in parallel, and this one was made from a series circuit to a parallel circuit, and we calculated here because the currents are different. But if we calculate it here, where the currents are the same, then it will give you the wrong answer. because it doesn't really make sense to give you the right answer since the current is the same. It will of course be different. It will be 10.6, which will be automatically wrong. So be careful when you apply this version. I won't recommend you to do it this way, to be honest. Like, I'll recommend you to calculate this short one, or actually I'll recommend you to like find a specific one. You know, if you want to like find the current to here, here and here, just apply this formula that we applied here. Okay, actually let's make it like, let's find the peak values. So that'll be times square root 2, that'll be equal with 6.76 times square root 2. That'll be 9.56 sine 1000 t plus 50.2 degrees times 2 square root 2, and that will be equal with, so that's 13.52. That will be 19.12 sine 1000 t minus 39.8 degrees. It's not asking us to calculate the peak values, but if you want to do them, it's good practice to them. 0.62 times square root 2, that will be equal with 30.58 sine 1000 t plus 140.2 degrees. Alright, so we calculate also the small i's in these three parts. Alright, now as I said, like, I'll show you how to apply, how to calculate it separately as well, which is in this case here. So let's do that now. Okay, so we know the angular velocity, so we can easily calculate XL1 and XL2. So then XL1 will be equal with 12 milli times 1000. And what, that one is just be equal with 1.2. 12 times 10 to the minus 3 times 1000. Yeah, that's just equal with 12. So then XL2, it's equal with 24 millihertz times 1000. Now be equal with 24 ohms. Alright, ohms in here as well. So now we kind of like make the circuit this way. There you go. This is how it looks now. It's got 12 ohms in here, it's got 24 ohms in here, and coming inside is this current here. So that current, as we calculated here, will be 13.52 at an angle of minus 39.8 degrees. Alright, so now we can just apply the voltage divider rule. And the voltage divider rule, if I remember it right, it was, actually I don't remember it right. It was something along the lines of, okay, let's call this one XL1, and this one call it XL2. Okay, so now let's call this one ZL1 and ZL2. The formula, it will be I inside Z1 will be equal with Z2, no, I L1 is equal with Z2 times I total, which is this one here, divided by ZL2 by ZL1 plus ZL2. That will be equal with, so ZL2, that will be this one, that's 24 ohms and an angle of 90 degrees plus, because it's an inductor. It's not quite obvious actually. There goes inductor now. Multiply by 13.52 at an angle of minus 39.8 degrees. This one will be 24 at an angle of 90 degrees plus 12 at an angle of 90 degrees. Well, this will be a lot easier actually compared to the other ones that we did. The other ones had the resistor in a different component. This one it's easier because it's the same component, so we can just simply add them together because they have the same angle. So then that will be equal with, so let's see, let's do the top one first. So 24 times 13.52, what will that be? 24 times 13.52, that will be 324.48. 324.48 at an angle of, so 90 minus 39.8, 50.2, divided by, and then this ones give the same angle, so that will be simply be 36 angle of 90 degrees. So that will be equal with, so 324.48 divided by 36, that will be equal with 9, this just leave it like 9 amps, and then the angle will be 50.2 minus 90, and that will be equal with an angle of minus 39.8 degrees. Alright, so that's the angle, doesn't really change. Now let's calculate the other one. So this one was for IL1, which is, I'm sorry, the wrong page. Where did I put it? Is it this one? Yeah, it's this one. Okay, which is this one, IL1, a current of 9 amps at an angle of minus 39.8 degrees is coming through this one here. Now let's calculate for the next one, which will be IL2. That one will be equal with, so the top one changes but the bottom one stays, so that will be 12 at the angle of 90 degrees times 13.52 at an angle of minus 39.8 degrees divided by 36 at an angle of 90 degrees. That will be equal with, so let's see here, 12 times 13.52, that will be 162.24, and it will still be the same angle of 50.2 degrees. All right, and it will be divided by 36 angle of 90 degrees. Now we can just do like 162.24 divided by 36, that will give us 4.5. So then IL2 is equal with 4.5 at an angle of minus 39.8 degrees. We can add those, and that would be IL2, which will be the current through this one here. And again, we can check if the calculations are correct by just adding them together. So then when you add them together, so IL1 plus IL2, that will be equal with 13.5 at an angle of minus 39.8 degrees. All right, now to like the last step will be to convert this one into a no, actually no, that's it. Yeah, that's it actually. I don't need to convert it into rectangle and back to polar, because this one is already 13.52 at an angle of minus 39.8, and we got the same answer when you add them to those two together. So that's how you can find out a specific one if you wish. If you wish, you can also find for the capacitors, or you can also find for the resistors. But at that point, that will just be me repeating myself. Good. So this will be the end of the lesson, of the two-part lesson. This is one of the more complicated ones for now. So because it's simpler compared to the other ones, and it took also longer to solve, because I also made it into, I simplified it into 3 components: resistor, inductor, capacitor, and then I further simplified into a series with only one resistor and one inductor, and even further simplified, making it a capacitor that has only one resistor and one inductor. So you can, I find it fascinating that you can take such a big circuit like this one and just boil it down and simplify it to just this or this. But anyway, so that was all for it for this time. Next time we'll do a combination of series and parallel at the same time, combined together inside the same circuit. These ones were separate ones, so only series, and there was only parallel. Thank you again for watching my videos, and hopefully you find them very helpful, and hopefully I'm good at explaining the material, and hopefully you understand how to do them. I don't know, I feel like I'm doing it good. I mean, like, I'm taking step by step. First I showed you complex numbers, then I showed you how to do it in series, and now I showed you how to do it in parallel, and next I'm going to show it to you how to do it in series and parallel, which is not very different from these two again. What I'm worried is when we're going to do it with network theorem, because network theorem it's a lot harder. But once we understand network theorem with AC circuits, then that's it. Nothing can stop us, because there are only two sources really. It's either AC or DC. And once we master AC sources, and we already know DC sources, then that's it. We don't have anything else that we need to cover when it comes to basic electronics. After that, as I said, we are going to go to transistors and amplifiers. But don't worry, again, I'll take it slow and I'll build it up till the harder stuff, which will be like AC sources, amplifiers, and transistors. But anyway, so that was it for this week. And again, thank you for watching, and I'll see you next time. Bye.